Okay, so this is to find the principal stress of the element. Okay, so based on the transformation that we're given, this is, I'm going to call this our point Z, our point Y, and our point X. Okay, so it's an element, so it's 3D. So we see what our stresses are like. So we know that stress Y and stress Z, stress X and stress Y is equal to 0. Stress Z, we are aware that it is having compression 95.6 times 10 to the power 6 Pascal, and then we know that shear YZ is equal to shear ZY, and this is equal to minus 19.998 times 10 to the power 6 Pascal. Okay, we can call this as close as 20. So we are also aware that shear XY is equal to shear YX is equal to 0, and shear XZ is equal to shear ZX is also equal to 0. Okay, so we construct Mohs circle, and we know that our stress allowable is at 160 times 10 to the power 6 Pascal. Okay, so we're going to draw a Mohs circle. So this will be our minus 120, 100, minus 80. I'm going to draw my Mohs circle to up to 160 for 20, 40, 60 to explain a certain things that we observe. Minus 160, 140, 120, 100, 80, 60, 40, 20, 0. And I'm going to go to the other spectrum. Okay, I'd like to elaborate on something. And 20, 40, 60, 80, 100, 120, 140, 160, normal stress. And then we have shear. So this is our shear stress. So 20, 40, 60, 80, minus 20, minus 40, minus 60, minus 80. So 20, 40, 60, 80, minus 20, minus 40, minus 60, minus 80. Right. So what I'd like to elaborate is the allowable stress. Okay. So for our diagram over here, we realize that anything outside this red box, the material will fail. Okay. So I know I've not taught this yet, but I want you to get this information. So anything that's out here, the material will fail. So you realize that anything above 80 megapascal, why 80 is because of Tresca. Later on, I'll describe what's Tresca in another chapter. So the shaded region are the no-go zone. Okay, so based on Tresca criteria, is that the tau max will be half U. Okay, so that's why the maximum shear is at 80. Okay, then we know our stresses. You look at our stresses. So we have our stresses at 95. So this is doing Mohs circle again. So 95. So this is 90. So I'm going to eyeball 95 is somewhere around here. Okay, 95. And then we have 20. Okay, so or 19 points, so we have 20. Then we have another minus 20 over here. Okay, so we know that point Z is minus 19, and so the shear is based on rotation of the element clockwise. Down here is anti-clockwise. So if you look at Z, it's going to be going in a clockwise direction. So it's at the top. So this is your point Z. Right, directly opposite over here will be your point Y. And where everything is 0, this is your point X. Okay, I'm doing 3D mode circle now, more or less. Okay, so you can do your calculation. Then we know that it's a pretty standard formula where stress average, which is correspond to the center of circle or center of circle, correspond to your stress average. So to calculate stress average will be equal to 95 minus 95.6 plus by 0 divided by 2. So minus 95.6 divided by 2 is equal to minus 47.8 megapascal. Right? So 47.8, I'm going to sketch this out. The center of the circle, roughly, approximately, somewhere around here. 47. So this is 47.5, 47.8. No, this is 45, 47.5. So it's going to be somewhere around here. So you can draw a straight line. Okay. And from here you can plot your circle. So to calculate radius of the circle, which is tau max. So tau max will be equal to square root of 47.8 squared plus by the shear, which is 19.998 squared. Okay, so 47.8 squared plus by 19.998 squared, square root of, so it's equal to 52.73 megapascal. Okay, so we just discover what is our maximum stress. So our principal stress 1 and 2 will be equal to minus 47.8 plus or minus 52.73. Okay, so stress 1 and 2 is equal to, so 47.8 plus by 52.73, so it's minus 100.53 megapascal, and the other one is equal to 4.93 megapascal. Okay, so the other one is 4.93. So when we draw the circle out, so this is just approximately, all right, and then is 52. Okay, so this is your mole circle. So this circle over here, right, you can see This circle is for your YZ plane. Then you can have another one over here, the smaller one, just about 100, 50, 50. So the smaller one, slightly smaller one, this one is for your XZ plane. And finally, this circle over here, we can draw physically, is for your XY plane. Okay, so this is how we construct 3D mold circle, which we will teach later on. But anyway, so you found your the stress 1 and 2 is minus 150 to 4.93. So the stress allowable of 160 megapascal is safe. Okay, right, so that's all we have for now. There's a lot of content in here, so some of like how to get principal stress you have to know. 3D mold circle I'll teach more later on. Thank you.